You are asked to find the average rate of change. That is synonymous with finding the average slope. So I'd say, Shay, you took it one step maybe too far, because if A said, find the average rate of change, and then said, does f of x ever have that average rate of change?
Yeah.
Well, then you'd have to test for differentiability there, and perhaps it's not differentiable. And so if that's not differentiable, which I would agree it's probably not, then that average slope may or may not actually ever show up as a value for f prime. But if f was differentiable, then we'd know for sure that f prime would reach that value at least once.
Okay.
It just didn't ask us to go there. This would be like a little step on the way towards an MBT sort of question, but it didn't take us all the way there.
Okay.
Follow-ups on A. Any other questions on that one? Wasn't the hard part about this one as far as the mechanics, making sure the right piece got in the right place? Careful with that. It's easy to mess stuff like that up. Got to be in radian mode.
Is that the same answer as this?
Yeah, it's like, I think we figured it out. It's like, what, 2 minus cosine, 2 minus 2 cosine 2 minus root, or plus root 3, all over 3. Yeah. Okay, then, here is an answer for B. Here it asks for the full equation of the tangent line. So you needed the point of tangency, which was pi comma pi over 2, or pi plus 2. And the slope of the tangent line, as crazy as it seems, the slope of the tangent line is just 1, right? Maybe pretty surprising to get such a simple result. It is what it is. You put it all together into the same the point slope form, and hopefully we're good. Questions on B as far as details there? Number one mistake I've been seeing with questions like this is sometimes the question will ask for the equation of the tangent line, and then the response is only the slope. Or it asks for the slope, and the response is the whole equation of the tangent line, right? You know what that tells me? I totally get this. If you're doing that, it tells me that you're probably thinking of just like little snippets of dots. Like you just see the words tangent line, and you start doing something. Instead of reading the whole question and saying, oh, it wants the whole equation of the tangent line, not just the slope. Or it only wanted the slope. It didn't want the whole equation. I get it. We're probably never going to be perfect on that. We have habits and patterns of ways of doing things, but just an encouragement to you. All right, then the last one is C. Hey, on C, did you notice that at no point does it say what is the absolute minimum? Or for what x value is the absolute minimum? It never once asks you what the absolute minimum is or where it is. What does it ask you? Does this thing even happen? Does it exist? Will there be a minimum? What's the one condition that if fulfilled will guarantee this? Continuity. So if we can prove that this graph is continuous, then we know for a fact we'll have a maximum and a minimum. This is the extreme value theorem, or the EVT. So here, I look back at my equation up here and I realize, well, that square root function will be continuous over its domain, and the trig function also will be continuous over its domain. So the only issue is the place where they join. If they do join, that would be when x is negative 2. Or 0, sorry. 0. So I'm going to test that out. So I do the limit from the left of 0, and the limit from the right of 0, and f of 0. And I compare all those values, and I get negative 2 for all of them. Since all of those are negative 2, I mean, you guys have seen this a bunch of times at this point. We know for certain that f is continuous, and if f is continuous, we know for sure that f has an absolute minimum somewhere on that interval. At no point did I find it. I just asked, does this exist? Because of continuity, it does. Weird question, right? Bless you. How many times in your math past have you been asked, hey, does this answer exist? Isn't it almost always what's the answer? So, a little bit different, yeah.
How would we deal with it if it wasn't continuous? Because couldn't it be?
So if we had done this and instead of getting what we got like -2 equals 3 equals -2 or something,
Yeah.
right? So then I think at that point we just say we don't know. So the
Okay.
EVT is kind of it's more of a positive statement. It's saying if f is continuous on our interval, then f does have a minimum and a maximum. So you can't take it and reverse it and say, well, because f isn't continuous at some point or another, then f definitely doesn't have a min or a max. It still could. So we just have to say, we don't know. We'd have to do further analysis to know this for sure, but the continuity certainly causes doubt as to whether we have max or min. Okay. Any other thoughts? All right, cool. So this week, these next 2 days, all about optimization, finding maximums and minimums. We're going to take it more to an application perspective, but I just want to let you know it's still all about the first derivative test and the second derivative test. Okay. So with that in mind, we have 2 examples. We're going to do 2 of them today. Would you all look at our first one right here? And I'm going to give you a kind of a statement here that hopefully will help you. And we'll use this as needed. We used it twice in the other class. So check this out, what I wrote up on the board. Of course, optimizing is just the generic word for finding a minimum or a maximum, like either one. So if you are trying to optimize blank, we'll need to set blank prime equal to 0 or perhaps d8. Okay? I don't really care what you put in the blank, but whatever is in this blank, the exact same thing goes in that blank. Okay? So whatever goes here, the same thing goes there. Like word for word, exactly the same. Fair enough? Okay, so I'll read this one out loud to you. On a given day, the flow rate F, measured in cars per hour on a congested roadway, is given by that equation, where V is the speed of traffic in miles per hour. What speed will maximize flow rate on the road? Does this pass the who cares test? Do you see why someone might care about this? Have you ever driven on I-25 through downtown? At some point while you were doing that, did you realize that that stretch of roadway was not necessarily optimized for flow rate for this day and age? Like, have you ever driven through that stretch and said, wow, there was no traffic from Santa Fe to I-70? Let me know when you did that, and I would like to drive at that same time you did. Because I've never driven that stretch through downtown and been like, wow, traffic sure was light, maybe at 1 a.m. or something, but who knows? I'd rather be sleeping at that point. Hopefully you see why a traffic engineer or a civil engineer designing a bridge or an on-ramp or something, or perhaps you as a driver, would be interested in this, right? Do you see why someone might care about this? I hope you do. Okay, so I'm going to give you guys a few minutes to try this. Please take that little framework I wrote up there on the board for you and consider that here as you work on this. Maybe after a moment or two, I'll check in with you and see how it's going. say? What does your church say? Said read. Yeah, the only thing that can make the whole fraction zero.
Now read.
Woo! Just having smarter by the day. Nice work.
Be smart. Can it just be a negative number?
But that's just the derivative.
Okay, so it's not.
We're actually doing DP. So when we did DP,
So then it's
So
never. I'm not crazy, right?
what's DBX?
I think so.
So what's DBX?
This is the new Redworks campus. Is nice.
It's sick. It's big.
It's a D&D if there was a 0 and a 1.
There's a lot going on. There's a lot to think about with our because you see like you just see like per hour. You might be tempted to think, oh my gosh, I gotta do DDT. In the end, it says what speed will maximize. So we're really looking for in the end, V equals something is what maximizes what. And of course, this is what they would use to maybe set the speed limit, right? Yeah, so the other task is to track that as well. So I'll put this to you back by the same square. So what are we trying to minimize here?
We're talking about the top of the
Your points are top and that one's are backwards. So if optimizing F, set F. That is already
So you get 33.16.
maximizing maximize.
So that's one of our numbers on
Cars
today,
per
right?
hour. Makes sense, right? So maximizing. Positive maximizing, positive maximizing. That's why that generic perspective is good. What am I trying to maximize? In prime. Hey, I know that this does not say anything about justifying anything, but we want to be in practice of always justifying, explaining our answer, so that when the time comes, we will have done that a lot. So I would encourage you, those of you that maybe have found a critical point, take it a step further. This is Calculator Active, by the way, for the arithmetic.
How is this?
Yep.
They're both negative.
Oh, this is the bottom. Gotcha. Yeah. Yep. So use your calculator to figure out what that actually is, and then use either a first derivative test or a second derivative test. So v is speed. So v cannot be negative. So it's on the right hand or the positive side of this.
Imaginary.
Like 22 plus 8.
So that's
G is 1 and 2 is like 0.
You get 33.
Can I give you a piece of the solution here? Feel free to check this out. This is your derivative. you did need to find f prime, and I used the quotient rule to do so. So I'm gonna zoom back out here a little bit. That'll be your first part of your answer. Cool.
Why am I so down? Or something?
So no, your test goes on.
There we go.
How are you doing first?
You get point zero zero.
Yeah, so you do the, so you do the guy who runs. If it goes from positive to negative, then it's going to matter.
So you just do enough.
Again, it doesn't say to justify yourself, but please do explain, please justify why you think what you think.
I just picked the school.
And then you just test zero and.
What else do you?
Test like 100 or something.
And it would have to go from negative to negative.
We're doing all this. Can you double divide by
Decimals?
Negative.
Oh man, you were one level past when you used to.
Yeah.
Let's look at passive.
33.6 miles per hour.
That was amazing.
Okay, I'm gonna show you a little bit more here. So you needed to set f prime equal to 0. And then I got a critical point of 33.166 equals V.
So since double is imaginary, do you just ignore it?
So there shouldn't be, did you set the denominator equal to 0? So if you set the denominator equal to 0, you do get something or other I.
Oh, but I guess if you just like multiply that up, like then it goes away, right?
Well, we're trying to find out where that fraction is 0, and the only part of that fraction that could make the whole thing 0 is the numerator. The denominator cannot make the fraction 0.
But can't it make it not indifferent?
Yeah, but there's no real zeros of the denominator either, right? There's only imaginary zeros
Yeah.
of the denominator.
Yeah,
So
because, like, if you
the idea of balance is to become but at least not for real.
Okay, so at this point, after
I'll show you. Yeah. Hey guys, here's how you could finish. I chose to use the first derivative test, and there's kind of the whole solution there. The reason why I chose to use the first derivative test, just to be blunt, I thought it would be easier to use the first derivative test than the second derivative test, because I looked at that first derivative and thought, if I'm going to use the second derivative test, I'm going to have to do the derivative of that, and I'd have to do another quotient rule, and I would have to do a chain rule or some kind of an algebraic expansion within that quotient rule. And I just thought, man, I've got the calculator on this one. I'm just going to use that to do a first derivative test. That's what my little sign chart is down below there. I tested out 32 and 34, and assuming that I pushed the buttons on the calculator correctly, I got those numbers. So I found that f prime went from a positive number to a negative number around the critical point, and that means that f has a relative maximum at my critical point. So whether you use the first derivative test or the second derivative test, it really does not matter as long as you do it correctly. Although it would matter in terms of energy and time spent, I think this is easier in that perspective, so I use this. So questions or comments? Okay.
Is a good way to explain this to say that f prime changes from positive to negative at the point?
Exactly, yeah, so I've got that off to the right there.
Oh,
So if you found your critical point, and then you found the sign change pattern of f prime around that critical point, that's exactly what we want. That would be fantastic. Okay.
Did you include units in your answer, like, when you had us about to match that?
That's a good question. You know, it wasn't really specific about that. I think that's a really good practice. I tend to fall on the side of, if you didn't ask me for units, I'm probably not going to give them. But if you did, that's great. It's probably a better practice to do that, as long as you're doing it correctly. Others? Okay, so I'll still stay open for questions on this one, but if you feel, okay, I'm pretty good, please flip over to the next question that has to do with cars on a car dealership lot. I really, really hope that this passes the who cares test. I really do, because in our day and age, data and analytics are a huge thing, right? I guarantee you that Amazon has done stuff like this all the time. How on earth do they keep stuff in all their warehouses and promise 1 day or 2 day delivery? I guarantee you that Walmart is doing this right now on a much more complicated level, because they're trying to catch up and surpass Amazon, right? Basically, they're saying, how do we take all the stuff that we receive and get it to the places that we need so we can deliver it to the people that buy us? Okay, we're talking about supply chain, getting things in the right location at the right time. It's huge. Has anybody ever been frustrated with Amazon? Like you bought something and it said 2 day delivery or 1 day or even same day delivery, and then they can't fulfill that promise? I remember a year or two ago, we had some guests that decided to come visit us over Christmas, kind of a last second thing. And I was like, oh man, I bet you they're going to bring gifts. So I better get something. And I tried Amazon, and I got something I could get in like 2 days, and I didn't get it. Not for like 3 weeks. And I went back, I emailed them like, hey, I bought this from you specifically because of the whole 2 day thing, and it's for a gift. And so I don't care if you deliver it to me in 3 weeks. I need it now, and you said you could give it to me now. They had a problem with this, didn't they? They said they could have it in a certain spot, but their analytics were wrong. Whatever, right? So I hope this passes the who cares test. I really do. Local car dealership is getting new cars from the manufacturer at a certain rate, and they are selling cars at a certain rate over the time interval, the open time interval 0 to 10. We want to know on what day is the number of cars at a minimum. Yeah, minimum, relative minimum. Maybe some data analyst would look at this and say, wow, on day such and such, that's when the number of cars is at a minimum. That actually coincides with one of our busiest days historically. Maybe we should adjust our deliveries so that they have more cars on this busy day, right? Maybe you would adjust what you do based on these numbers. Okay, so have you guys work for a little while? I'll need about 5 minutes to show what I think is a good answer. Yes, ma'am.
Ready up.
No, is this the same as like the water? Is it R minus?
Okay, let's think about what that would be. So are you thinking like,
So then we do R minus less than 7.
well, how would you do that? Like, would you do R of 10 minus R of 0, or S of 10 minus S of 0, or R of 10 minus S of 0? What would that, the numerator, if you're going to do the numerator, would definitely be 10 0, I suppose.
Yeah.
No, what was the numerator? It's not piecewise like our warm-up.
Yeah.
Right?
We do the derivative of that.
So it's not like you would use R for one part of the domain and S for the other part.
We're finding the number
of cars and that's the rates.
So you're just plugging it into Y equals.
Set both R prime and S prime equal to 0.
Let me direct you up to here. It says, if optimizing blank, set blank prime equals 0, and the same thing needs to be in the blanks, right?
Yes, if optimizing S of T said S prime.
Read carefully. At no point does it says maximize or minimize S of T. Never says that. No point does it say that either. Read. You're just snippeting this. You're just saying, S of T, it's a math thing. R of T, it's a math thing. And you're not the only one. I hear other people talking, they're doing the same thing. Read it as a story. What are we trying to minimize? The number of cars. Okay, so we're trying to minimize that. So if optimizing number of cars, then we need to set number of cars prime equal to 0.
So R.
Does R stand for the number of cars? What does R stand for? What does S stand for?
The amount of cars.
What does S stand for? Just read it. It's up there. What does S stand for?
The rate.
So you told me a second ago that R is a rate. And you just told me just now that S is a rate.
No, that's not.
They're interacting, aren't they? How are they interacting? What is R causing? R is causing the number of cars. R is making the number of cars equal. So, how should we? And how can we tell if the number of cars is increasing?
I'm a double prime.
They're already technically.
Or you can just. Did you just do the first of the test?
Okay, let's take another 3 or 4 minutes and get as far as you can. If you're on this, you might be finishing up fairly soon. I don't know, I might give you a little bit less time because I feel like I need to intervene a little bit with my discussions and such. Yeah, hey guys, hey, listen up, please. Listen up. I think I'm actually going to intervene as I'm walking around. I'm seeing probably the majority of folks need a little intervention here. Okay, so I was working with a student and I wrote up on the board. Check it out. It says, if optimizing number of cars, set number of cars prime equal to 0. Would you guys agree with me that that's what we're trying to do? It says, at what time on the open interval is the number of cars at a relative minimum? So I'm trying to minimize. This is where it's so important that you don't use generic words like them or it. Because if you just said, I'm trying to minimize it, or minimize them, or even minimize the cars, that's better, but it's not all the way there yet either. You want to really steer clear of that. I'm trying to minimize the number of cars. There are a lot of you. You're going to be changing course after this conversation. So up there, if optimizing number of cars, set number of cars prime equal to 0, would you guys agree with me that, I'm going to write this on the screen, that number of cars prime, isn't that really, or couldn't that be maybe better be said, rate of change
Yes.
of number of cars?
Perhaps.
Like if we were going to actually use language that applies to this question, it's the rate of change of the number of cars. So guys, here's the thing. Please pay attention. R of t, based on the wording and the units, R of t is already a rate of change of the number of cars. You can see it in the units too, right? It's cars per hour. So R of t, as it currently stands, is already the rate of change of the number of cars, but
Okay.
isn't there also another rate of change? There's this other one. S of t is also the rate of change of the number of cars. Again, the units tell you a good story here. So, in other words, R of t and S of t, these are already components of the rate of change of the number of cars. So there is no need, in fact, I would say it is incorrect, to try to find R prime or S prime of anything. Okay? So the way you would start this is actually you would say R of t is the rate causing the number of cars to increase. S of t is the rate causing the number of cars to decrease. Therefore, we would say R of t minus S of t equals 0. Because R and S are already the appropriate rates, the ones that we're looking to use, they are already that. So we talked about this before. This is actually that moment when not doing the derivative shows understanding. Weirdly enough, even though it's calculus class, not doing the derivative shows that you have good understanding of what you're doing with this. Doing the derivative of whatever is put in front of you, in this case, actually is not good. Weird, I know. Okay, so R of t minus S of t, we're setting net rate equal to 0. And if I remember right, so this is clearly calculator time, right? This is a pretty ugly equation to try to solve on your own. By the way, I think sometimes people make assumptions. I just want to be careful with this. We are not setting R of t equal to 0 and S of t equal to 0. That would also be incorrect. I want to find where the net rate is 0. And would you agree with me that this is actually just a different version of the same equation? Like if I just added the S of t over? Yes. So we're basically finding when the rate in and the rate out are equal. Wouldn't that be where a maximum or a minimum would happen? Where the two competing rates even out. That's where you would have a low point or a high point. Anyways, so you use your calculator to solve this. When you do, you get t equals what? It's 2 point something, I think.
817.
Sounds about right. Yep, 2.817. You could use the zero finder. You could use the intersection finder. Either of those would work fine, depending on how you set up your equation. Bless you. And then, bless you. Here, I don't know how you feel about this, but you could very easily use the first derivative test or the second derivative test. Anybody get this far and use one or the other? Can't you use Math 8?
Oh.
Calculator's active. So couldn't you do this? I love it. That's awesome. Couldn't you do R prime of 2.817 minus S prime of 2.817? You could just do this straight up on Math 8. And I don't know what number you get, but I'd be willing to bet that it's a positive number. You could do the first derivative test too. I'm just using, you know what's weird about this? Is R prime minus S prime is the second derivative test, right? It's the second derivative of the amount of cars. I know there's a single prime on there, but technically this is the second derivative test because it's the second derivative of the amount, and that's true because R and S are already rates of change of the amount of cars. I don't know. Did you guys get any numbers for, did you do Math 8?
It's a positive 1.39.
1.39 something?
Yeah.
Okay, so 1.39 something. That, of course, is a positive number. And because we have a positive second derivative at our critical point, we know for sure that the amount of cars function would be concave up. Therefore, we'd have a minimum, right? Minimums go with concave up. So I'd say something like this, because R prime of 2.817 minus S prime of 2.817 is positive, the number of cars is minimized at t equals 2.817. I got one too many equal signs in there. There we go. We already proved that 2.817 was a critical point, and we just found that the
That's because, R prime minus S prime,
was positive,
which means it's concave out.
which means we use avoid the it.
Which means R prime minus S prime.
No, it doesn't mean that R prime minus S prime is concave up. R prime minus S prime is positive. It means that if there was a function describing the amount of cars, that would be concave up.
I thought about this.
You could also do the first derivative test. I think you'd find the first derivative test, R minus S would go from negative to positive.
Is that just supposed to say minimum? Ours is.
Minimized. Sorry. MIN apostrophe D is short. I ran out of room. Sorry.
The number of cars is Mindy.
Mindy. Well, come on. That's common sense. So anyways, yeah, sorry about the abbreviation there. So yeah, if you wanted to, you could have said, you could have done the first derivative test, and couldn't you have done R of 2 minus S of 2? And I bet you that would have given you a negative number. And then you could have done R of 3 minus S of 3. I bet you that would have given you a positive number. So then you could have said, hey, at the critical point, R minus S goes from a negative to a positive. Therefore, the amount of cars is minimized. That would have been just as valid. Got no problems with it. Maybe the big takeaway is this. Reed, please put your phone away. For goodness sake, I should not have to ask you to do that. Right? The big takeaway, and we've talked about this before, but I think it's worth saying again. Please be careful that you read for meaning, not just to do the derivative of whatever's put in front of you. I'm not saying that that's easy. I actually think that that's pretty hard sometimes. But take the time to ask yourself, is the thing that I'm being given, is this already the derivative that I need to be using? And if so, I don't need to do prime of anything. Or, like in number 1, you might look at it and say, wow, that's already a rate, but I'm being asked to maximize the rate. So I do need to find the derivative by doing, in that case, a quotient rule. So nobody's saying that it's easy. All I'm asking you to do is put your energy into that, because I know that you know how to do the details of it. Just put your energy into what am I given, what do I need to do with it, and I think you'll get better and better. Tomorrow will be like today. See you then.